Trigonometry, the study of triangles and the relationships between their sides and angles. In this video, we will learn how to find an unknown side in a right-angled triangle using the ratios sine, cosine, and tan. We will focus on questions where the unknown is in the numerator of the ratio, in other words, the top part of the fraction. The trigonometric ratios are sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tan equals opposite over adjacent. We will abbreviate these ratios to sine equals O over H, cosine equals A over H, and tan equals O over A. Okay, so we will use these ratios to find an unknown side in a right-angled triangle. So example number 1. Find the length of the side A, correct 2 decimal places. So the first thing that we always do is we label our triangle. So always do the hypotenuse first because it's the easiest. It's always opposite the right angle. So opposite the right angle is the hypotenuse. Then the second one we label is the opposite. It's always the side opposite the angle in question. Okay, and then the last side that we label is the adjacent. It's always the remaining side once you do the previous two. Okay, and then once you have it labeled, you have to see which two sides are you going to use for your ratio. So here I'm going to use the opposite because I'm looking for the side A, and I'm going to use the hypotenuse because I already know what the hypotenuse is, so it's 12. So then I look at my ratios, sine, cosine, and tan, and I decide which one of those uses the opposite and hypotenuse. So you can see there that it's the sine ratio. So what we do is we use the sine ratio then to build our solution. So what we know is the sine of the angle 35 equals opposite over hypotenuse, which is A over 12. So now our job is to solve this equation to find what is A. So firstly what we'll do is we'll solve it using our balancing method. So what we can see here is A is divided by 12. So then to cancel the 12, we use the reverse operation, multiplying by 12. And we're going to multiply both sides by 12 to maintain balance. Okay, so then what I have after that is 12 times the sine of 35 equals A. Okay, so the sine of 35 is a ratio, and you have to go to your calculator to find what that ratio is. So get your scientific calculator and find the sine button on it and press sine 35 and you'll get a ratio. Now a ratio is always represented as a decimal or a fraction. Most of the time your answers here on the calculator will be in decimal forms except for one or two special cases. So it'll generally be a big decimal like we see here, and what I usually do is I take 4 decimal places to maintain accuracy. Okay, now sometimes in an exam paper, maybe an ordinary level, junior cert, they say what's the sine of 35, correct 2 decimal places. So that's perfect, answer that like it's been asked, but in general I always take 4 decimal places. Okay, so now that we have our sine of 35.5736, what I'm going to do then is multiply that by 12. So all you have to do is to multiply that by 12, just press multiply by 12 on your calculator and it will give you the answer, multiplies it by 12 for you. So the answer here we can see now, multiply by 12 is 6.8829172236. Okay, now at this point that is the answer, that's what A is, but we're not going to write all of those numbers down. So go back to your question and figure out what did they ask us to do. They asked us to find the side A correct 2 decimal places. So this correct 2 decimal places, so 0.88 is 2 decimal places and the number after the 8 is a 2, which means that's less than 5, so we're rounding down. So my answer here is A equals 6.88. Okay, so that represents the length of A. Now, alternatively, what you can do is put your sine of 35 over 1 equals a over 12. And what you can do here is cross multiply. Okay, so cross multiplying is a little shortcut that we use when we have one ratio equal to another ratio. Okay, and actually it's used quite a lot in trigonometry because frequently we're equating one ratio with another ratio to find either an angle or a side. Okay, so to cross multiply, you just put an x there, and what you do is you multiply along each of the cross lines. So here we have a multiplied by 1 equals 12 multiplied by sine 35. Okay, now it's worth mentioning here that some teachers use cross multiplying, some teachers use the balancing method, but it doesn't really matter because if you look at these two lines that I've highlighted in red, they mean the exact same thing. So down here we have 1a equals 12 times the sine of 35, and up here in our balancing method our second line was the same, 12 times the sine of 35 equals a. So either way we find out that the side a that we're looking for is 12 multiplied by the sine of 35. Now also what's worth mentioning is that you can, when you get good at your trigonometry, go straight into the calculator with 12 times the sine of 35. Okay, now what you'll notice on the calculator here is you don't actually have to type in 12 multiplied by the sine of 35, and you don't need to use brackets to infer the multiplication. If you just type in 12 sine 35, the calculator understands that you mean for the 12 to be multiplied by the sine. Okay, so just typing it straight in, 12 sine 35, and we get the same answer here, 6.8829. Correct two decimal places then is a equals 6.88. Now you'll notice here the two answers. Using the balancing method, the a is on the right. Using the cross multiplication method, the a is on the left in the answer. It really doesn't make any difference. Both are all good. Okay. Example number 2. Find the length of the side x corrected two decimal places. So the first thing we do is label. So opposite my right angle is my hypotenuse, opposite my angle is my opposite, and my remaining one is my adjacent. So what two sides are we going to use? So we're going to use the opposite because we're looking for x, and we're going to use the hypotenuse because we know it's 15. So what ratio are we going to use? We're going to use sine because it is opposite over hypotenuse. So we're going to use the sine ratio then to build our solution. So we know that the sine of 42 degrees equals opposite over hypotenuse is x over 15. So using our balancing method, okay, x is divided by 15, so then to cancel the 15 we use the reverse operation, multiplying by 15. So multiply both sides by 15 to maintain balance. So then we have 15 times sine of 42 degrees equals x. So now we need to know what is the sine of 42 degrees. We'll find that ratio on our calculator. So go on to your calculator and find what is the sine of 42 degrees. And we can see that the decimal ratio is 0.6691306064. Okay, if you're writing it down, just take 4 decimal places or whatever you've been asked for. Okay, if you're not, just take that now, that ratio, and multiply it by 15. So multiply by 15, we get 10.0369591. Okay, now just go back to your question and you can see what have you been asked for. You've been asked for the side correct to 2 decimal places. So we can see here after the 0.3, after the 2 decimal places, we have a 6. So that's greater than 5, which means we'll be rounding up. So my answer then for x is 10.04. Okay, so alternatively then, we can put the sine of 42 over 1, and then we've created one ratio equals another ratio, which means we can cross multiply. So then we have x multiplied by 1 equals 15 times the sine of 42. And as I said, you can put that straight into your calculator. 15 sine 42 equals 10.036 rounded up to 10.04. So that is the length in units of the side x. Okay. Now, example 3. Find the length of the side y correct to 1 decimal place. So let's label our triangle. So opposite our right angle we have the hypotenuse. Opposite the angle we have the opposite, and the remaining side is the adjacent. So what two sides are we going to use? We're going to use the opposite because we're looking for y, and we're going to use the hypotenuse because we know it's 9. So which ratio uses O and H? It's sine. So then we're going to build our solution using the sine ratio. So we know the sine of angle 25 degrees equals opposite over hypotenuse y over 9. So we have the structure right. Now we're going to solve for y by using our balancing method. So y is divided by 9. So to cancel the 9, we use the reverse operation multiplying by 9. So multiply both sides by 9 to maintain balance. So then we have 9 times the sine of 25 degrees equals y. So the sine of 25 degrees is a ratio, and you need your calculator to find out that ratio. So the sine of 25 equals 0.4226. Okay, then we take that ratio and we multiply it by the 9. And we can see we have 3.803564356. But go back to your question and find out how they want us to leave the answer. So it's correct to 1 decimal place. So after 1 decimal place here, we can see that after the 8 is a 0, so we'll be rounding down. So my answer will be 3.8. Now, alternatively, if we put the sine of 25 over 1, we've got one ratio equal another ratio, so we can cross multiply. So then we have y multiplied by 1 equals 9 multiplied by the sine of 25 degrees. And we can put that straight into our calculator. 9 sine 25 gives me my 3.8 answer. So y equals 3.8 units in length. Okay, so now one for you. Find the length of the side h correct to 2 decimal places. Now I have something I just want to talk about here first. So when you're labeling the triangle, you may abbreviate to a capital H, O and A. But please use capital letters. This is because in many questions they ask for the height h as a missing side, which can be easily confused with the hypotenuse. Maybe even use a different color pen for labeling. Okay? So go ahead, I'll pause the video and you try and do that yourself. Okay, so let's try and answer this question. So we already have it labeled, and we can see then we have to choose which two sides we're going to use. So we're looking for h, so we're going to use our opposite, and we know our hypotenuse is 16, so we're going to use our hypotenuse. So that means opposite and hypotenuse, we're going to use the ratio sine. So build our solution. We have then that the sine of the angle 51 degrees equals opposite over hypotenuse is h over 16. Okay, so either at this stage multiply both sides by 16 or cross multiply, and you will have h equals 16 multiplied by the sine of 51 degrees. And what you can do then is we have to find the sine of 51. So I'll get my calculator here. Let's see. Get my wee calculator. So you can either get the sine of 51, so press sine 51, and that's your ratio, 0.7771, and then multiply that ratio by 16 to get your answer. So my answer is 12.43, okay? Or as I said, you can put it just straight in and type in 16 sine 51. And as I said, the calculator understands that you mean for the 16 to be multiplied by the sine, and it gives us our answer 12.43. Now just check, how do we need to leave our answer? You can see it's correct to 2 decimal places, and after my 3 here, after 2 decimal places, I have a 4, which is less than 5, so I'll be rounding down. So it's 12.43. So h equals 12.43. And you can see we didn't mix up our h here with our with our hypotenuse because my h was a small letter and my hypotenuse we used a capital letter. Okay. Now example number 4. Find the length of the side B, and this time it's a whole number. So labelling my triangle, opposite my right angle I have the hypotenuse, opposite my angle I have the opposite, and the remaining side is the adjacent. So which two sides are we going to use this time? So we're going to use the opposite because we're looking for B, and we're going to use the adjacent because we know it's 8 units in length. We don't know the hypotenuse this time, so it's of no value. So which ratio uses opposite and adjacent? So looking through the top there, we can see that it is tan. So tan is opposite over adjacent. So using tan to build my solution, I have the tan of 37 degrees equals opposite over adjacent, which is b over 8. So using my balancing method then to solve, b is divided by 8. So then to cancel the 8, I'm going to multiply both sides by 8. So then we have 8 multiplied by tan of 37 degrees equals b. So tan of 37 is a ratio, so we have to use our calculator to find that ratio. So my ratio is 0.7535540,501. And then we're going to take that ratio and multiply it by the 8. So multiply that by 8 and we get 6.028432401. Now looking back on my question, we were asked this time to leave it as a whole number. So leaving it as a whole number, after my decimal point, I have a 0, so that means I'll be rounding down. So I'll be rounding down to the value of 6. So B is 6 units in length. Alternatively, I can put my tan of 37 over 1. So I have a ratio equal to a ratio, so I can cross multiply, which gives me 1 times b equals 8 times tan 37. That can go straight into the calculator to get b equals 6 also. Now, question 5. Find the length of the side x, correct 2 decimal places. So let's label. Opposite my right angle I have my hypotenuse, opposite my angle I have my opposite, and then the remaining side is the adjacent. So which two sides am I going to use? I'm going to use the opposite because I'm looking for x, and I'm going to use the adjacent because I know it's 10 units in length. So what ratio uses opposite and adjacent? It's tan. So build our solution using the tan ratio. So the tan of 38 degrees equals opposite over adjacent is x over 10. So we're going to solve this using our balancing method. So x is divided by 10. So to cancel the 10, we are going to use the reverse operation, multiplying. So multiply both sides by 10. So that will give me 10 multiplied by tan of 38 degrees equals x. So what is the ratio tan of 38 degrees? Check it on your calculator and we can see that it's 0.7812856265. Take that ratio and multiply it by 10. And we get our answer as 7.81285665. So go over to your question and find out how do they want us to leave the answer. It's correct 2 decimal places. So looking to our calculator here, after 2 decimal places, after the 1 we have a 2, which means that's less than 5, so we'll be rounding down. So my answer is 7.81. Alternatively, put your tan of 38 over 1 and cross multiply, and you get 1x equals tan 10 times tan 38 degrees. Put that straight into your calculator, and we have x equals 7.81 units in length. Now, example number 6. Find the length of the side y, correct 2 decimal places. So labelling our triangle, opposite my right angle I have my hypotenuse, opposite my angle I have my opposite, and the remaining side is my adjacent. So which two sides are we going to use this time? So we're going to use the adjacent because we're looking for y, and we're going to use the hypotenuse because we know it's 13 units in length. So which ratio this time uses adjacent and hypotenuse? So if you look to the top there, you can see this time we're going to use cosine. So using the ratio cosine to build our solution, we know that the cosine of 27 degrees equals y over 13. Okay, So solving that using our balancing method then, we're going to multiply both sides by 13. And so we have 13 times the cosine of 27 degrees equals y. So what is the cosine of 27 degrees? So find it on your calculator. This time we're using the cosine button. So cosine 27 equals 0.89100. Then take that ratio and multiply it by 13. And we have our answer 11.5830. Look back to our question and we've been asked for the side y correct 2 decimal places. So after the 0.58 we have a 3 which is less than 5, so we will round down to 0.58. So my answer is 11.58, or alternatively put your cosine of 27 over 1 and cross multiply. So we have y equals 13 times cosine 27, which we can put straight into the calculator and get our answer 11.58. So hopefully at this stage you're getting a little bit quicker at your solutions and finding your own rhythm and what way you like to solve out your equations. Okay. Now example number 7. Find the length of the side B correct to 1 decimal place. Okay, so looking at this triangle is flipped upside down. The right angle is on the top left, but this won't throw us off at all if you just stick to your steps. So labeling, opposite the right angle we have the hypotenuse, opposite the angle we have the opposite, and then the remaining side is the adjacent. Okay, and then which two sides are we going to use? So we're going to use the adjacent because we're looking for B, and we're going to use the hypotenuse because we know it's 10 in length. So which ratio uses adjacent and hypotenuse? We can see that it is cosine. So use the cosine ratio to build your solution. So the cosine of 67 degrees equals adjacent over hypotenuse, which is B over 10. So we're going to solve this using our balancing method. So multiply both sides by 10. So we can see that B equals 10 multiplied by the cosine of 67. So find the cosine of 67 on your calculator, okay, and multiply by 10. Or at this stage now, you're probably going straight for your calculator and typing in 10 cos 67 and getting your answer straight away. Okay, so my answer there is 3.9073. But look back, what did they ask us for? They asked us to represent B correct to 1 decimal place. So after my 0.9, I have 0, so I will round down to 3.9. Okay, and you can see that our solutions are starting to get shorter the more we understand. Now the reason why I took it very slow and kept going step by step is because in some exam questions they do break it down and they actually ask the question step by step, particularly for ordinary level junior cert. So it can be confusing if you're asked step by step if you've always been doing it a quick shortcut way. So it's important to understand your steps, and especially for later on when we're going to be moving backwards, it's very important to understand your steps forwards so that we can reverse the steps backwards. Okay, but at this point now you're probably getting very good at doing out your solutions, and you can use your own shorthand, whatever you feel comfortable with. And remember, alternatively then, we can use our cross multiplying, and again we just get B equals 10 times the cosine of 67, which is 3.9. Now finally for our last question, question 8, find the length of the side D where D is an element of the natural numbers. So that means D is going to be a positive whole number. So you can see that this question is a little bit different because we have two angles to choose from. So what I'm going to show you here is that it doesn't matter which angle you choose, you will get the same answer. Okay, so first one we're going to choose is the angle 30. So let's label our triangle as if the angle in question is 30. So opposite my right angle is my hypotenuse, opposite my angle is my opposite, and the remaining one is my adjacent. So looking at this, the two sides I'm going to use are the opposite because I'm looking for D, and the hypotenuse because I know that it's 12. So what ratio uses opposite and hypotenuse? It's sine. So let's set up our solution then using the ratio sine. So the sine of 30 equals opposite over hypotenuse, which is d over 12. So using balancing, multiply both sides by 12. So we have 12 times a sine of 30 equals d. Now, what is the sine of 30? This is one that I wanted to show you. So the sine of 30, when you type it in, you get a half. And that's because it's just a special angle where it can actually be written as a fraction and not just a decimal. Okay? So if you see that come up, there's 5 or 6 special angles where the answer will pop up as a fraction instead of a decimal. If you don't want to use the decimal, just press the SD button and it will just change it straight into the fraction point or the decimal for you, 0.5. Okay? So then take the 0.5, multiply it by 12, and we get our answer to be 6, which is what we were expecting. We were told it was a natural number. So the answer is 6. Now what I want to show you then is if I choose 60 to be my angle to focus on, let's get rid of this. This time we're going to use 60. Label my triangle. So opposite my right angle will be my hypotenuse. Now opposite my angle will be my opposite, and the remaining one is my adjacent. So this time if we're using 60, the D is the adjacent with the hypotenuse. So adjacent and hypotenuse is cosine. So this time we would be using cosine to structure our solution. So my solution then would be the cosine of 60 degrees equals d over 12. Multiply both sides by 12. And then find what is the cosine of 60. Okay? Now if you check your calculator, you can see it there. The cosine of 60 equals a half as well. Okay, so when we multiply that by 12, we're going to get the same answer, which is 6. Okay, so you can see it doesn't matter which of the angles you choose to use. So this actually brings us to a lovely property to finish off, that the sine of an angle actually equals the cosine of that angle taken away from 90. And the easiest way to see this is to just look at a few examples. So let's see what is the sine of 10 degrees. So the sine of 10 equals 0.1736. Now, according to this, that should be the same as the cosine of 90 minus 10 is 80. So what is the cosine of 80? It should be the same. Same answer. Let's try another one. What is the sine of 30? Oh, it's a half. Remember we saw that. So the same should be then for what's 90 take away 30 is 60. So the cosine of 60 should be the same. And it is. And lastly, we'll do one more. The sine of, let's say, 81 degrees. 81 degrees equals 0.9876. Take 81 away from 90, we've got 9. So what's the cosine of 9? The cosine of 9 degrees, not 99. Cosine of 9 degrees equals the same answer, 0.9876. Okay, so I hope this video helps you out to just settle into trigonometric ratios. Okay.